Okay, so now we're going to be using solving equations that are simple, but they're going to have several steps. Now, step one, whenever you're solving an equation and an inequality as well, but right now we're looking at equations, is that whatever variable you're looking for, whatever is added or subtracted to that variable, then that's what you're going to do the opposite of that operation in order to cancel it out. Because remember, when you're trying to solve for a variable, whether it's a or x or c or r, whatever it is, you want to get it alone. So the very first step is whatever is added or subtracted to it, you need to eliminate that. So let's take a look at here. These are two questions. The first thing they're asking is solve for c, solve for the variable c. And on this side, solve for the variable r. And I'm going to explain them together because I want you to see that sometimes we're used to seeing the variable on the left side, but it doesn't have to be. It's an equation that both sides are balanced, right? They're equal to each other. So sometimes the variable comes on the left and sometimes it comes at the right. But the difference, there is no difference in the way that you solve it. Okay, so this we're going to try to get c alone. That's what it means, solve for c. And for this one, we're going to get r alone. So the very first move you have to ask yourself is, and I say this in a very basic way, what is plus or minus to the variable? In this case, it's plus 9. In this case, it's minus 1. Now, what is the opposite of adding 9? Well, the opposite is subtracting 9. What is the opposite of subtracting 1? The opposite is adding 1, and that's exactly what you're going to do. As when we're subtracting 9, you're going to do it to the left side because our purpose is to eliminate that 9, and you're going to do that to the other side of the equal sign as well. Okay, and it has to be, numbers work with numbers, right? So this, we're going to subtract 9 and subtract 9. And remember, the subtraction property of equality, which is what we're using here, says if you do the same thing to both sides of the equation, you're okay. You're just maneuvering things around, but you're not changing. It's still balanced. Here, this is minus 1, so the opposite of subtracting 1 is adding 1, but you have to do it to both sides. Plus 1, plus 1. Now, what's the result of this? 2c is not affected because you're subtracting 9. It's a number. Numbers go with numbers. Variables go with variables. The same variable. So you end up with 2c plus 9 take away 9, 0, equals 11 take away 9, which is 2. And here's what you see. See? 2c plus 0. On this side, okay, this is minus 1. So what's added or subtract to the r? Minus 1. The opposite of minus 1 is adding 1 to both sides. And I do it in a different color so it'll stand out more. Now, having done that, negative 1 plus 1. I always like to do this with negatives and positives. It's super easy to think of money because we handle money all the time. If you owe $1 and you have $1, well, you can use your dollar to pay your debt. How much money do you have left? 0. 3R, so we haven't changed any of that. Remember, numbers go with numbers. You can't add plus 1 to everything. Sometimes people make that mistake. They'll say plus 1, plus 1, plus 1. No, no, no. Once, and it has to be a number with a number. Okay, 8 plus 1, I have $8, I have $1, I have $9. So I have 9 equals 3R plus 0. Here I have 2C plus 0 because 9 take away 9. I have $9, I owe 9, I pay, I've got 0 money. 11 take away 9 is 2. It's a little hard to see, but that is a 2. Okay, so that means now we have to simplify it a little bit. So we're going to clean this up. What's 2C plus 0? 2C. What's 3R plus 0? 3R. And here it is. See? Cleaning up. 2C equals 2, which leads us to the next step. This is a two-step equation as an example. All right, so I have 2 times C. 2 times C equals 2. I got to get rid of that 2 there, and it's 2 times. What's the opposite of times? Division. Exactly. So what I'm going to do is I'm going to do the division property of equality. When I divide here and here, I have to do it on each side. And I'm going to divide both sides by, what's C multiplied by? 2. So I'm going to divide by 2 and divide by 2. In this case, I have 3 times r, and I want to get that r alone. I don't need to isolate the variable. 3 times, the opposite of 3 times is divided by 3. So I'm going to do that to both sides, divide by 3. And here goes. So that's step 2. First step is add or subtract what's with the variable. The next one is multiply or divide to get that variable alone, which is what I just explained. So 2c equals 2. Well, we divide both sides by 2, and I did it in light blue here. And 9 equals 3r, you divide both sides by 3. Now, what happens? 2 divided by 2 is 1. C equals 2 divided by 2, 1. 9 divided by 3, 3. Equals 3 divided by 3, 1 times r. Now, 1 times c, any number times 1 is the same number. 1 times r, r. Now, see, this is doing the exact same process. The only thing is it's on the right side and this one's on the left. But it's still the same answer. I mean, not the same answer, but it's still the same steps. 1 times c is c. We're simplifying that. Equal to 1. 3 equals 1 times r, r. 3 is equal to r. Another way to write it is r is equal to 3. And we're done. Now, we can check both into the original equation. Let's see. So if I substitute c with 1, it would be 2c plus 9 equals 11. I'm going to change that c to a 1. Here it is. 2 times 1 plus 9 equals 11. Okay? Here, 2 times 1 is 2 plus 9 equals 11. That's a true statement. We know that c is equal to 1. It comes out true. So let's check this one. If we use 3, we go to the original. 8 equals 3 times 3 minus 1. 8 equals 3 times 3 minus 1. Now, we have to remember PEMDAS. So, I don't have anything to solve in the parentheses, right? I have to multiply first. If I say 3 minus 1 times 3, the whole thing's messed up. We always check the parentheses. There's nothing inside the parentheses. Check the powers. All right, there's no powers. So now multiply or divide. Oh, I multiplied these two. 3 times 3 is 9. Take away 1, 8. And there's your answer. So it comes out true. And these are 2 basic problems. I'm going to go over another 2. Okay, so these 2 that we just did, the first 2 we did, were based on, dividing both sides to get to the final answer, right? Now this one is going to be multiplying. So let's check it out. Sometimes we have x divided by 6. Remember, when we have a fraction, it's another way to say division, plus 4 equals 15. Our first step, if you will recall, is there any number? I want to solve for x. Let me write that here. Solve for x. Okay? Is there any number that's plus or minus to the x? And I look for my plus. I'm like, oh yeah, 4. Okay? That means I got to move that one first. So I take this, and it's plus 4, so I'm going to put minus 4 on this side, minus 4 on that side. One time. And that's, since I subtracted, that's the subtraction property of equality that we used. So we did it to both sides. Okay, next step, we get x divided by 6 plus 0 equals 11. 4 minus 4, I have $4. I pay $4, I have 0. Okay, now I simplify this a little bit. And I get x divided 6 equals 11. I need to get rid of that 6. And it's x divided by, what's the opposite of division? I multiply both sides by 6, which I can write as 6 over 1. This side and this side. Using, since I multiplied both sides by 6 over 1, which is 6, multiplication property of equality. In the 2 previous examples, I divided. So that's why that works. Okay, now that gives me 6x divided by 6. 6 times x, 1 times 6, equals 11 times 6. 6 divided by 1 is 6, which gives me 6 divided by 6 is 1. Let me see, I thought I had written this down previously. So this is 1 times x equals 66, which 1 times x is x equals 66. And if you want to check it, put it here. 66 divided by 6 plus 4.